Okay, this is second part, and as I have said that I think this will really take more than 7 8 parts. Let's just start what's about the second part. It's very small presentation. I think 5 or 6 slides or 7 slides. Okay, resolution limit and resolving power. So many of the students get confused of what is resolution limit and resolving power, because see, in case of visual acuity, I'm just going to add small details, and I'll try to explain visual acuity in detail as far as possible. I'm going to do same about visual field. I'm going to take small steps, and that's the plan. Okay, so angular resolution, what is resolution limit and resolution power? Okay, resolving power. So angular resolution refers to the minimum resolvable angle, which sometimes come mar, minimum angle of resolution, isn't it? Separation of spatial pattern. So minimum resolvable angular separation in spatial pattern. Spatial pattern means, what is spatial? In a space, isn't it? What is temporal? In a temporus, which means in a time. So let's take an example. This is the sorry, let's take an example, or wait, let's take an example. This is the pattern: 1 2 3 4 5 6 7 8. This is the pattern. In a space there is a pattern. Okay, blue white blue white blue white. And let's take example, eye is here first. Then this pattern makes an angle somewhere between this. If same eyes and distance makes a smaller angle, isn't it? So the angle made by this pattern at eye, which is actually the spatial pattern is in space, but that spatial pattern make the angle at eye. And angular resolution refers to the minimum resolvable angular separation. The separation in terms of angle, the separation lies in space, but we calculate that separation in terms of angle. An angle where? Definitely at nodal point. So that's the angular resolution. So angular resolution, so the angular resolution limits refer to the minimum angle of resolution. We already know that, isn't it? Mar and all the time mar. Okay, minimum angle of resolution. The smallest angular separation formed by two discernible point. Because if we want to separate, so let's take example. If there is a 2 point, and let's take an example. This is the, here is a nodal point. So this is the angle, isn't it? If you move this eye nodal point from here to far distance, don't you think the angle decreases and decreases and decreases as the eye moves away from that? And somewhere it comes to minimum angle of resolution. And then after, if it decreases below the minimum angle of resolution, there is no resolution. We cannot see. Okay, that's the concept. The reciprocal of the resolution limit is resolving power and resolving ability, isn't it? So, smaller the minimum angle of resolution, better the resolving power, isn't it? So, don't you think 1 minute of arc mar is then compared to 0.5 minute of mar is far better, isn't it? And this is greater 0.1 minute of mark, 1 minute of mark, minimum angle of resolution, isn't it? So smaller the mark, better the resolving power, because resolving power or resolving ability is basically reciprocal of resolving limit, and resolving limit means mar, basically minimum angle of resolution, isn't it? So the smaller the minimum angle of resolution, larger the resolving power, isn't it? 6 by 6 means mar is 1, but 6 by 3 means mar is 0.5, isn't it? So 0.5 is mar, 0.5 minute is far better, isn't it? So 6 by 6 means 30 cycles per degree, 60 cycles per degree, isn't it? So that's what I'm talking about. Okay, see, in this case, resolution limit and resolving power. Limit means the separation expressed either in angularly or spatially between the closest distinguished image point, isn't it? The smaller the better. Resolution limit is smaller the better and expressed in a unit of angle. Example, arc minute or uh, minute radian or length in mm. But the resolution limit is exactly opposite, reciprocal of the separation between closest distinguished point and image through the instrument. It's larger the better. For example, see cycles per minute PR 30 cycles per degree is better than 15 cycles per degree, isn't it? 60 cycles per degree is better than 30 cycles per degree, because 60 cycles per degree is 6 by 3 and this means 6 by 6, isn't it? So simple, resolution limit, reciprocal, resolving power. So sometimes you see such an equation, visual acuity equals to 1 divided by MAR, minimum angle of resolution. That's why sometimes you can see visual unit of visual acuity is a reciprocal of arc minute minus 1. Sometimes you see arc minute, reciprocal of arc minute is a unit of visual acuity. Okay, simple as that. That's why visual acuity is not about how far two discriminable objects are. It doesn't matter. See, let me give you an example. How far? Let's take an example. If two object, let's take an example. This is one object, and this is another example. The distance between them are kilometers and kilometers. It doesn't matter because we can consider the length also at kilometers and kilometers. Does it matter? No, it doesn't matter. If it is 1 kilometer, we can consider this as a 100 kilometer, isn't it? Then the angle made by separation between 2 points can be less than 0. Let's take example 0.5 minute of arc. Is it possible humanly we can see this thing? Less than, if it's very less than 0.5 minute of arc, it's a separation between this at our nodal point. Is it possible? No, not at all. Where resolving capacity is roughly 1. Yes, up to 6 by 3 some people can see. Obviously it's depend upon individual and individual, but it's not, human cannot see 0.1 minute of arc. If mar is 0.1 minute of arc, is it possible? Not at all. It's not recorded till now. So it doesn't matter the separation between two things. It matters how far our nodal point is and what is the angle between these two things, isn't it? So it is not about how far two discriminant objects are. It's about how small their angular separation is. Angular separation means angle made at the nodal point of our eye. So it's not about just this yachts, it's about this yachts too, isn't it? It matters, really matters. So it's not about the separation between 2 points. It's about obviously the distance from the nodal point too. Yeah, it's really important. Really important. The smaller the minimum angle of resolution is, the better the visual acuity, isn't it? It's always better. 0.5 is far better than 1 minute of arc because it's 6 is 6 by 3. Okay, it's 30 cycles per degree, it's 60 cycles per degree. And the third thing, visual acuity is the resolving power, and that is defined as the reciprocal of MAR. It's always defined as the reciprocal of MAR, isn't it? Minimum angle of resolution. When you reverse it, you'll get visual acuity. So this is the concept of resolving power. Okay. So finally, the reference from only one book I have taken, that is from Professor George Ismail, is my favorite. Please pick this book and just see what happens. It's a magical book. Okay. So Bistan, choose.